All right, let's do section 5.3, part 2. So we're still solving quadratic equations by graphing and factoring. The factoring is just going to get a little more difficult. Let's finish up some vocabulary words, though. Quadratic expressions can have 1, 2, or 3 terms. Quadratic expressions with 2 terms are binomials. Quadratic expressions with 3 terms are trinomials. You see that prefix bi and tri. Okay, bi means 2, tri means 3. Some quadratic expressions with perfect squares have special factoring rules. I would write these, circle them. You're going to refer to them quite often. I see that difference of 2 squares, when you have the difference, and that's a square and that's a square, factoring is quite easy. You get a plus b and a minus b. Let's try our first problem. The binomials are generally easier than the trinomials. So we're just going to set this up into an equation. Subtract 25 from both sides. Set it equal to 0. Okay, we have the difference. You see here this minus sign means difference of perfect squares. Okay, that's a perfect square, and that's a perfect square. And if I go back, so here, you take the square root of that. A is 2x, and b is 5. Factoring will give us, okay, plus and minus, okay, 2x plus 5, 2x minus 5. You should have learned this in Algebra 1. Hopefully I'm just refreshing your memory. And then we're just going to set them equal to 0 and solve. 2x plus 5 equals 0. 2x minus 5 equals 0. Subtract 5 from both sides. X equals negative 5 halves. Add 5 to both add 5 to both sides. X equals positive 5 halves. So we found the roots of our given equation. You see this next one, the numbers are a little bigger and things get a little bit harder. But first let's get everything into our equation. I need it set equal to 0. 18x squared minus 48x plus 32. I always want my a term in my standard form to be positive. Just makes life easier. Now I'm going to ask myself, can I factor anything out of this to make the numbers smaller? Because smaller numbers are easier to factor. I have a greatest common factor between the 3 of these numbers as 2. So I'm going to factor out a 2. I get 9x squared minus 24x plus 16. Now if I divide both sides by 2, the 2 magically disappears, and I'm left with 9x squared minus 24x plus 16. Okay? Now, if you go back a few pages in the slides, you're going to notice that this is an a squared minus 2ab plus b squared, which is called a perfect square trinomial. Okay, this is, a is 3x, and we get 3x, b is 4, and in the middle, so our a term is 3x, our b term is 4, in the middle you get 2 times a times b. If you page back a little bit to those equations you wrote down, that's what it's going to break out to be. So it's pretty simple. We get 3x minus 4, 3x minus 4 equals 0. Okay, solve. 3x minus 4 equals 0. Add 4 to both sides. You get x equals 4/3. Because each factored parentheses are the same, you only have to do it once. Your roots, you have one root, and it's the same. Let's try another one. Again, here we used a perfect square trinomial, so this breaks up into a minus b quantity squared, which we used right there. Okay, you try. Find the roots of the equation by factoring. You're going to use one of those perfect square trinomials, which is a squared minus 2ab plus b squared breaks up into a minus b quantity squared. So figure out what a is and figure out what b is. Push pause, please. So a equals x, b equals a equals x, b equals 2. The middle is 2 times a times b, which is true. So we know that we've used the perfect square trinomial, and we can factor it quite easy into x minus 2 squared, which is the same as x minus 2, x minus 2. Okay, if you solve that, you get x equals 2. Okay, you try the next one. Push pause, please. Again, here we have, once I set this up into an equation, I have a binomial, which is the difference is right there, of perfect squares. 25x squared is a perfect square, 9 is a perfect square. So I can do, this is a plus b and a minus b. A is 25x, b is 3. So pretty simple one. Okay, next example. If you know the zeros of a function, you can work backwards to write the rule for the function. I'll go through an example to explain. Write a quadratic, these are the instructions, write a quadratic function in standard form with the zeros 4 and negative 7. So that means x equals 4 and x equals negative 7. Let's set that into 2 sets of parentheses. If I take this and I try to solve, or I set it equal to 0, I would subtract 4 from both sides and get x minus 4 equals 0. Okay, those are the same. And here, if I set it equal to 0, I would get x plus 7 equals 0. So I have x minus 4 and x plus 7 equals 0. And let's FOIL. FOIL, if you remember, is first x squared outer plus 7x inner minus 4x, and last minus 28. Simplify, you get x squared plus 3x minus 28 equals 0. That is standard form. Okay, you try this one. Do the same thing that I just did on your own. There you go, standard form. It actually works out to be the difference of perfect squares, which makes sense. And that's it. We'll see you tomorrow.